Okay, in this video we're going to be talking about different ways to integrate using ln, and the problems are going to look different than the ones that we have done before. Specifically, if we look at this integral, this is the integral of x squared plus x plus 1 divided by x squared plus 1. And when we looked at the examples yesterday, it was important to see that when we use ln, we look at the bottom, and if the derivative of it is on the top, then that's what we can use to integrate and use our u substitution. But here we have the same degrees or same exponents. We also have to use this process that we're about to go over if the degree on the bottom, so the exponent on the bottom, is larger or smaller. Degree on bottom is smaller. And we'll look at those two examples. So we have x squared and x squared. So we can't use substitution and find our derivative. So what we have to do is break up these fractions. And the only way to break up these fractions is something that that you probably learned way back in Algebra 2. So we need to go over this process. To break these up, we have to divide the polynomials. And the way that we do that is with polynomial long division. I know that sounds scary, but it follows the process of regular long division. So here we have x squared plus x plus 1, and it's divided by x squared plus 1. So when we set up our quotient, it's going to look like this: x squared plus x plus 1. And our process for dividing these follows the same exact process for dividing other numbers. So for instance, if we're going to divide 974 by 3. So what we do, the first thing that we do is we look at 3 and we decide what we multiply it by to get 9. In this case, it would be 3. That's the closest we can get. So that's the same step for this x squared. We just look at the first terms. We don't have to worry about that plus 1. But we decide, okay, what do we multiply x squared by to get x squared? Well, they're the same thing, so it's just going to be multiplied by 1. Our next step in regular long division is multiplying these two together and putting what we get on the bottom. So 3 times 3 is 9. So here, when we multiply, we actually have two things to multiply. So that plus 1 is just along for the ride, but it does get multiplied. So 1 times x squared is x squared. Then 1 times 1 is 1. And I'm going to put it under the whole number. I'm not going to put it under the x because those aren't like terms that I can combine. So when I do that, I'm going to combine these. If I look at my regular long division process, I have to subtract. 9 minus 9 is 0, and I drop down the 7. So I have to subtract both of these terms. So x squared minus x squared is 0. 1 minus 1 is 0. And the last thing that I have to drop down is plus x. Now, if I could, I would repeat this process over here. I would drop down the 7. How many times does 3 go into 7 would be twice. 3 times 2 is 6, and I would subtract until I got a remainder. And 14, so 4, and I would get 12. I like to work down there. So my remainder is 2. Here, my remainder is x because I cannot multiply x squared by anything to get x. I would have to divide, and I can only put multiplying things on top. So our remainder for a number, we would write 2 over 3 would be our remainder. So plus 2 over 3. Here, we're going to have plus x over x squared plus 1. Doing this means this is what we are now going to integrate. So we are going to integrate plus 1 plus x over x squared plus 1 dx. So these are the same thing. It's just actually divided instead of written as two separate things. So now we can integrate this because if we look at this, 1 we can integrate is just a regular power rule. Here we do have a denominator. If we take the derivative of x squared, we'll get something with x in it. When we split these up, Sometimes it's easier to split them up before you integrate. So this would be the integral of 1 dx plus the integral of x over x squared plus 1 dx. And here, this follows the pattern of what we were looking at yesterday. If we use substitution for the bottom, x squared plus 1, and find du, which will be 2x dx. Well, I have an x, I just need a 2, which means I have to put a 1/2 in front. So when I not quite integrate, let's leave the 1 dx, we're not there yet, but this can be rewritten. We have plus 1/2, 2x dx makes du. We integrate x squared plus 1, so we have 1 over u. And now this is an ln integral. So when we integrate 1, we get x plus 1/2. The integral of 1 over u is the ln of the absolute value of u. I'm just going to leave that blank because I know that I'm going to put x's back in. Need a plus c. And then I can put my x's back in and get x squared plus 1. If you want to, you could rewrite this with a square root. So it would be x plus ln times the square root, or of the square root of x squared plus 1. We can take away those absolute values. That's always going to be positive. So under the square root, we can just write x squared plus 1. And then c stays on the back. Either of these last two answers is completely correct and fine. It doesn't matter which one. The new process here is polynomial long division. I'm going to do one more example with division. So if we look at this integral, we have the same pattern, but actually instead of the same powers on the top and bottom, the bottom power is smaller. In order to break these up, you still have to do polynomial long division. So we have to set up our long division, and we're dividing by x squared plus 2. There's one thing about setting up your long division. You have to have a place for every power after x to the 4th. So if we were counting down, we would have x cubed, and then x squared, and then x, and then just the number is the order, standard form of our polynomial. So you have to have placeholders for everything that's missing. We don't have an x cubed, so we need to put a 0 to hold that place. We don't have an x squared, so we need to put a 0 to hold that place. So when we write our equation under the division sign, we'll have x to the 4th plus 0, because 0 doesn't change anything, x cubed, plus 0, x squared, plus x, and then we have minus 4. Because the x and minus 4 we do have in our quotient on the top. So now we can divide. So we look at x squared and x to the 4th. What do we multiply x squared by to get x to the 4th? That would be x squared. And then we multiply that back out to both of these. Remember, the 2 doesn't matter until we multiply. So x to the 4th times x to the 4th is, or x squared times x squared is x to the 4th. X squared times 2 is 2x squared. I'm going to put that under my x squared term. So 2x squared. And then we always subtract in this step in division. So both of these are going to be negative. X to the 4th and x to the 4th makes 0. We just have 0x cubed. And 0 minus 2 is negative 2x squared. And then we drop our next term down. So plus x. So now we look. X squared, what do we multiply by to get negative 2x squared? Well, negative 2. And then we distribute it to both. So we have negative 2x squared. And we have plus 4. So I'm not going to put it under x. I'm going to put it over here. Plus. Oh, that's a negative. Very good. Okay, there we go. So that would be a minus 4. Negative 2 times positive 2 would be a negative 4. And then we subtract these. They're both negatives. When we subtract a negative, they both become positive. Negative 2 plus 2 is 0. Those should always cancel out. And then we also need this negative 4 to drop down. So negative 4 plus 4 is also 0. So when we have our remainder, it's just x again. So we have plus x, and our remainder is always over what we divided by. X squared plus 2. So this is now what we're going to integrate because it fits in with our integral rules better. So when we integrate, we'll have the integral of x squared minus 2 plus x over x squared plus 2 dx. And so when we do this, the first two things are power rules. So I'm going to break those up and leave them in the front for a second. X squared minus 2. And then we have the integral of x over x squared plus 2 dx. And so this last one follows our pattern. We have x squared on the bottom, so if we make that our u, x squared plus 2. So we have du, sorry about that, is 2x dx. Well, we have dx, we have 2, we need a 2. Or we have dx, we have x, we need a 2, so we have to put a 1/2 in front. So finally what we're integrating, I got my dx here, so x squared minus 2 dx plus 1/2 the integral of 1 over u, and that becomes the u. When we integrate this, we get x cubed over 3 minus 2x plus 1/2. The ln of 1 over, or the integral of 1 over u is ln of the absolute value of u. We'll put something else for u and make sure that you have your plus c at the bottom. U is x squared plus 2, so that's what goes in here. If you want to, you can rewrite this. We could write it as 1/3 x cubed minus 2x is going to be rewritten, that's it. This can be a square root, and we can get rid of the absolute values because this is squared plus 2. Will always be positive, so we could write plus the ln of the square root of x squared plus 2, and then don't forget your plus c. Again, these two on the end, either one of those is fine for your final answer.